1.6 Rational expressions. A pastry shop has fixed cost of $280 per week and variable cost of $9 per box of pastries. The shop's cost per week in terms of X, the number of boxes made, is 280 plus 9X. We can divide the cost per week by the number of boxes made to determine the cost per box of pastries. Notice that the result is a polynomial expression divided by a second polynomial expression. In this section, we will explore quotients of polynomial expressions. Simplifying rational expressions. The quotient of two polynomial expressions is called a rational expression. We can apply the properties of fractions to rational expressions, such as simplifying the expressions by canceling common factors from the numerator and the denominator. To do this, we first need to factor both the numerator and the denominator. Let's start with the rational expression shown. We can factor the numerator and denominator to rewrite the expression, and then we can simplify that expression by canceling the common factor. How to? Given a rational expression, simplify it. 1. Factor the numerator and denominator, and 2. Cancel any common factors. Example 1. Simplifying rational expressions. Simplify x squared minus 9 divided by x squared plus 4x plus 3. Solution. Factor the numerator and the denominator. Cancel common factor, x plus 3. Analysis. We can cancel the common factor because an expression divided by itself is equal to 1. Q&A. Can the term x squared be canceled in example 1? No. A factor is an expression that is multiplied by another expression. The term x squared is not a factor of the numerator or the denominator. Multiplying rational expressions. Multiplication of rational expressions works the same way as multiplication of any other fractions. We multiply the numerators to find the numerator of the product, and then multiply the denominators to find the denominator of the product. Before multiplying, it is helpful to factor the numerators and denominators, just as we did when simplifying rational expressions. We are often able to simplify the product of rational expressions. How to? Given two rational expressions, multiply them. 1. Factor the numerator and denominator. 2. Multiply the numerators. 3. Multiply the denominators. 4. Simplify. Example 2. Multiplying rational expressions. Multiply the rational expressions and show the product in simplest form. X squared plus 4x minus 5 divided by 3x plus 18 multiplied by 2x minus 1 divided by x plus 5. Solution. Factor the numerator and the denominator. Multiply numerators and denominators. Cancel common factors to simplify. Dividing rational expressions. Division of rational expressions works the same way as division of other fractions. To divide a rational expression by another rational expression, multiply the expression by the reciprocal of the second. Using this approach, we would rewrite 1x divided by x squared divided by 3 as the product of 1 over x multiplied by 3 over x squared. Once the division expression has been rewritten as a multiplication expression, we can multiply as we did before. How to? Given two rational expressions, divide them. 1. Rewrite as the first rational expression multiplied by the reciprocal of the second. 2. Factor the numerators and denominators. 3. Multiply the numerators. 4. Multiply the denominators. 5. Simplify. Example 3. Dividing rational expressions. Divide the rational expressions and express the quotient in simplest form. Rewrite as multiplication. Factor the numerator and denominators. Multiply numerators and denominators. Cancel the common factors to simplify. Try it, number 3. Divide the rational expression and express the quotient in simplest form. Adding and subtracting rational expressions. Adding and subtracting rational expressions works just like adding and subtracting numerical fractions. To add fractions, we need to find a common denominator. Let's look at an example of fraction addition. 5 over 24 plus 1 over 40 equals 25 over 120 plus 3 over 120 equals 28 over 120 equals 7 over 30. We have to rewrite the fractions so they share a common denominator. Before we are able to add, we must do the same thing when adding or subtracting rational expressions. The easiest common denominator to use will be the least common denominator, or LCD. The LCD is the smallest multiple that the denominators have in common. To find the LCD of two rational expressions, we factor the expressions and multiply all of the distinct factors. For instance, if the factor denominators were x plus 3 multiplied by x plus 4 and x plus 4 multiplied by x plus 5, then the LCD would be x plus 3 multiplied by x plus 4 multiplied by x plus 5. Once we find the LCD, we need to multiply each expression by the form of 1 that will change the denominator to the LCD. We would need to multiply the expression with the denominator of x plus 3 multiplied by x plus 4 by x plus 5 over x plus 5, and the expression with a denominator of x plus 3 multiplied by x plus 4 by x plus 3 divided by x plus 3. How to? Given two rational expressions, add or subtract them. Factor the numerator and denominator. 2. Find the LCD of the expressions. 3. Multiply the expressions by a form of 1 that changes the denominators to the LCD. 4. Add or subtract numerators. 5. Simplify. Example 4. Adding rational expressions. Add the rational expressions. 5 over x plus 6 over y. Solution. First, we have to find the LCD. In this case, the LCD will be xy. We then multiply each expression by the appropriate form of 1 to obtain xy as the denominator for each fraction. 5 over x multiplied by y over y plus 6 over y multiplied by x over x. That gives us 5y over xy plus 6x over xy. Now that the expressions have the same denominator, we simply add the numerators to find the sum. 6x plus 5y divided by xy. Analysis. Multiplying by y over y or x over x does not change the value of the original expression because any number divided by itself is 1, and multiplying an expression by 1 gives the original expression. Example 5. Subtracting rational expressions. Subtract the rational expressions. 6 over x squared plus 4x plus 4 minus 2 over x squared minus 4. Solution, we factor. Multiply each fraction to get LCD as the denominator. We multiply, apply distributive property, subtract, and simplify. Q&A. So do we have to use the LCD to add or subtract rational expressions? No, any common denominator will work, but it is easiest to use the LCD. Simplifying complex rational expressions. A complex rational expression is a rational expression that contains additional rational expressions in the numerator, the denominator, or both. We can simplify complex rational expressions by rewriting the numerator and denominator as single rational expressions and dividing. The complex rational expression a divided by 1 over b plus c can be simplified by rewriting the numerator as the fraction a over 1 and combining the expressions in the denominator, 1 plus bc divided by b. We can then rewrite the expression as a multiplication problem using the reciprocal of the denominator. We get a over 1 multiplied by b over 1 plus bc, which is equal to ab over 1 plus bc. How to? Given a complex rational expression, simplify it. 1. Combine the expressions in the numerator into a single rational expression by adding or subtracting. 2. Combine the expressions in the denominator into a single rational expression by adding or subtracting. 3. Rewrite as the numerator divided by the denominator. 4. Rewrite as multiplication. 5. Multiply. 6. Simplify. Example 6. Simplifying complex rational expressions. Simplify y plus 1 over x divided by x over y. Solution. Begin by combining the expressions in the numerator into one expression. Multiply by x over x to get the LCD as the denominator. Add the numerators, and now the numerator is a single rational expression and the denominator is a single rational expression. We can rewrite this as division and then multiplication, rewrite as multiplication, and multiply. Q&A. Can a complex rational expression always be simplified? Yes. We can always rewrite a complex rational expression as a simplified rational expression.